Hello there, this is Daniele from Toolchefs and welcome to this new video. Today we're going to have a look at avoidances, so both mesh and agent avoidances. So we're gonna build some examples from scratch, and we're going to make our agents avoid each other, avoid agents from another agent group, also avoid meshes, and then also we're gonna combine the agent and mesh avoidances together using the context steering module. Before we start building this example, it's important to note that whenever you are trying to approach these situations, try to solve basically an avoidance in a complex scene, you always use a locomotion system. A locomotion is a graph that lets atoms, in this case, blend animations depending on inputs, which in this case are going to be a linear input, so are going to tell the agent how fast the agent should travel, and also an angular, which is how much the agent is turning. By having these two inputs, then we're able to pick an animation that can then be used for walking or jogging, but also we are able to combining these animations together. If you just use, for instance, a clip or a state of a state machine that just has a clip like a walk or a jog, then Atom is not able to change the speed, because the speed is coming from the clip, which is just a walk or a jog. And then in that case, you're gonna have intersections. We're gonna see later how we can fix intersections once we have the simulation, but basically that is a post task that so you do after the simulation, which is not something that maybe you might want to do all the time. So to start, we're gonna create an agent group, and we're gonna add a grid layout and a locomotion module. Here we're going to use the main locomotion, which is the locomotion that we see here. This is in the default setup that is shipped with Atoms, but also the locomotion, we have some locomotion systems already configured for the agents from the Atoms agents bundle. Here we're going to already set the linear average num frames and the angular average num frame to 10. What this does is basically whenever Atoms finds a new value at each frame for the linear and angular velocity, it's gonna blend with the 10 previous values. So in this way you avoid having like weird pops during simulation. You allow Atoms to have to find a smoother transitions between the clips. On the other hand, you have to be careful with these values, because the higher they are gonna be, the slower your agent is gonna be to react to changes in the linear and angular velocity. So again, you might see agents maybe intersecting with each other, or maybe intersecting with a mesh. And this might be because, again, the value of these linear and angular average frames is too high. So in those cases, using a lower value is going to help. We're going to create a bit more agents. So let's start with 4x4. We're going to change the draw to skin so we can see them. And also let me change the random direction a bit, so that they just don't go straight. So if we press play now, we see that the agents are still in this, because we are not setting the linear velocity, an initial linear velocity. So here we're gonna do that. We're gonna add a metadata module with setting the target linear velocity. This is a double, and we're gonna say 130, which is the value for the walk. You see there, 130. So if I press play now, the agents are walking, but they are intersecting, which is not something that we want for sure. So we're gonna add an agent avoidance. Even if you use the agent avoidance, you still need to provide the target linear velocity. This is basically telling to the avoidance algorithm that this is the desired velocity for the agent. So here we're going to use RVO, which is the default, and we're going just to change in the locomotion system. We're going to disable the angular velocity for this example, and also we're going to set the linear velocity maximum to 130. What this does is basically whenever the simulation is playing, Atoms never sets a value higher than 130 when processing the agent avoidance. With this, we're gonna make sure that the agents are never gonna start jogging or running or whatever. They're just gonna walk whenever, it's just the maximum speed that they can go is the walk. So if I press play now, we should see the agents avoiding each other. Also, we don't see anything like too poppy, too sharp. We see just this guy over here popping straight away. And this is because here we have a max turn angle which is quite high. Let's change it to 5. So now that pop should go away. So yeah, it's not as sharp as before. You could even set it to lower values like 1. But whenever you start setting very low values here, whenever you have large crowded areas, then it's almost impossible to avoid intersections. We're gonna see it later, but yeah, most likely the agents are gonna intersect. Also here you have agents just going in one direction, so having that max turn angle to a low value, it's feasible. But if you have a large crowded area, also agents coming from a low direction, you need to provide the agents. You need to give the agents a bit more max turn angle. So let's just set it to 5 for now. Another very important attribute on this module is the time to horizon. This value tells the agents how far in the future they can look for intersections. So if this value is 2, which is the default, it works basically pretty much in a lot of situations. But if you want the agents not to look for intersections too far in the future, you can make it, set this value to a lower value, like 1, for instance, or 1.5 or whatever. Let's just keep it for 2 for now. Just as we go, we're gonna maybe change that value as well. Okay, so if we press play now, this is the simulation that we have. We are going to duplicate this agent group with the button on the shelf. Always use that button whenever you're duplicating agents. Sorry, agent groups, not agents. Then here we have the new agent group. I'm going to change the direction to -1 here, so they're going the other way. If I press play now, we see that the agents are intersecting. The agents from the same agent group, but they are actually intersecting the agents from the other agent group. Okay, so what we want to do here to avoid that is to make sure that we provide here an agent group. So for the second agent group is going to be the first agent group, and the other way around for the other agent group. Where is it? Neighborhood. This. Sorry, one thing before we keep going. If I select that agent group just quickly, we go here in debug. If I press debug, we see here you're able to see how the avoidance is working. So if I press play now, all these lines are telling you that this agent is finding other agents around. If you have a lot of lines, the avoidance could really be quite, let's say, poppy, or anyway, yeah, you could see a lot of agents like changing direction quite quickly. If you have lower values, like for instance, if we use 300, you're gonna have less lines because each agent is gonna find less agents to evaluate for the avoidance, which also provides more like smoother simulation. So that's actually one thing that I want to do. I'm gonna disable the debug so that we don't have too many lines in the viewport. Even here, let's do 300. So if I press play now, we should see the agents avoiding each other. That's great. And we don't have any intersections. The agents are going all over the place because they don't have a target point that they have to reach, but at least that is something that the agents are avoiding each other. One thing that I'm going to do now is I want to maybe increase the number of agents a bit, so maybe we can say 7 by 7 for this one and also for this one. Not 1 here and 7 there. So if I press play now, the agents are doing a pretty good job and they're avoiding each other. Actually, this is quite good. Again, they're going all over the places, but yeah, that's at least we see that they're not intersecting. If we change this value, the max turn angle, to 1, we're gonna see that maybe the agents are gonna intersect with each other. Let's see. Yeah, you see there. We have some intersections. Again, with 1, we have maybe less sharp turns, but we have more intersection. Also, this is maybe a scenario that you're gonna see a lot when you use like just one clip. You know, if you're just making the agents walk, and the agents are gonna intersect with each other. So to fix this case, let's say you have built a large simulation, then you still have some agents that are intersecting. You don't know how you can fix it. It's quite you know, like you're happy with the rest of the simulation, but you just want to remove the agents that are intersecting. What we could do is we can export this as a cache. So we're gonna select both agent groups and I'm gonna export them in the same cache. I'm gonna export it in this folder here, and then I'm gonna after export I want to replace these two agent groups with an Atoms group with a cache reader. So after the cache is done, we are going to use a tool that is called Agent Deleter that basically helps you removing agents that are intersecting during a simulation. So this is done now. If I close this UI and press rewind, the post action, what it did, it created a new agent group and it set the cache reader path to the cache that we just exported, while it basically hid the other two agent groups that were the original agent groups. So I'm gonna use here, I'm gonna set it to skin. So this is exactly the same simulation that we had before, but now what we can do is that we can say I want the tools agent deleter. So you can provide an agent group. Then you can say, I just want to remove the agents that are intersecting at this frame, which will be nothing because all the agents are actually from the start position. But also I want, or you can say maybe I want it to be in a frame range. So you can either use the UI frame range or the start and end. Let's use the GUI frame range. And also here you can say maybe a radius. So you can say, oh, I want them to be, when they're closer to than 80 units, then we're gonna, I want Atoms to filter those. Okay, so I'm gonna click run. Now Atoms is evaluating all the agents that are intersecting. And this is gonna be done soon. So 52 agents were deleted. So we have quite a few agents that have been deleted, but at least now we see that they're not intersecting anymore. So again, we reached to this point because we changed the max turn angle to 1. But anyway, there could be other situations where you know, you have like a lot of agents, they are intersecting for some reason, and the agent deleter tool can really help you with you know, cleaning up the shot. You could even you know, export the cache and filter the agents. It wouldn't be the same as if you filtered the agents with the agent filter module from the two source agent groups that we used, because that would actually change the simulation, the avoidance simulation, because you're actually removing an agent from the simulation that is being calculated. So this is another approach that you can use when you know, trying to clean up your shot and making your avoidance scenes work. Okay, so let's go to the next example. Okay, so now let's have a look at a mesh avoidance example. I'm going to create an agent group and I'm going to attach a grid layout to it. Okay, so grid layout, and then I'm going to use a state machine and another metadata module, which we're going to use set straight away. So for the grid layout, I'm going to set the grid size maybe to 6 by 6. Actually, let's put a bit more, say 8 by 8. The direction, I want them to face the other direction, the opposite direction. It's going to change the random direction a bit more. 250 here, 250 there. And then we can do random space 50 and 50. Okay, I want them to be in skin mode and we can see the textures. For state machine, I'm going to use the state 4, which is the if you go on the Atoms UI, it's the locomotion state, which uses the same locomotion that we used before, the main locomotion. And then here we need to set the target linear velocity, which is the initial velocity, to 130. Like so. So the agents are just working straight, nothing too fancy. First of all, I'm gonna create a create polygon plane. I'm gonna just make a very big plane like this. I'm gonna move it here. I'm gonna use this as just as a reference. It's gonna be useful, so we see if the agents are actually intersecting or not a bit better. And I'm gonna create some obstacles like some cylinders. Okay, maybe a bit thinner, sorry, like this. installer. Okay, gonna create a couple more. And this one over here. Remove all of them here. Okay, great. Now we can go and create a mesh avoidance module. So for the mesh avoidance, you can either use a mesh or you can use a night field. So for this example, I'm going to use a mesh for the first mesh avoidance. So just again middle mouse to click one of the cylinders and dropped it here. And then for the next two, I'm going to go and open add field manager. I'm going to click add. I'm going to call this one avoidance. Press plus, okay. And then what I want to do is I want to create a new mesh avoidance and set the I field here. So if now I press play, we should see the agents avoiding both this obstacle but also that obstacle. These obstacles in the back. They are intersecting each other, and this is because we don't have an agent avoidance yet, but that's normal. So we can now attach an agent avoidance. We want to make sure that the distance neighbor radius is not that big, so maybe even 200 could be better. And then I can press play. Okay, so we'll notice straight away something here. When there's like a packed area, so with a lot of agents, like that guy there, do you see that? He was actually going in one direction, trying to avoid the obstacle, and then he turned and went in another direction. This is because the mesh avoidance is trying to set a direction for the agent, but then the agent avoidance is actually overwriting the change from the mesh avoidance, and this is because the agent avoidance comes further down in the stack. So we have now this new module called context steering, which should always be placed at the bottom of the stack, which takes as input all the changes that all the previous directional modules did, and then it combines them in a better solution. So the inputs that I was referring to, they're actually map that they are actually being filled internally for each agent. You can check the context steering video if you want to know a bit more about this module. Now if I press play, the result should be better, although we might still see something weird. Actually, before I press play, I want to do something else here. Now the agents are gonna walk, and then they're gonna try to avoid the agents and the meshes. But as we saw before, they're gonna keep the direction once they turn. They're not gonna go. For instance, if you want them to go over here, there's no way all of them will go there, because they are now once they start turning, they will not keep this direction anymore. So what we want to do is we want to create a curve. So I'm gonna use I'm gonna just draw a curve here, like this. Let me just move it a little on the right, and we're gonna use that curve as a target. Okay. I would basically we're gonna use a follow target curve module for this example, but you could also use a follow target. Although I recommend not using the follow target, because if you use a single point, then all the agents are gonna basically be the agent group is gonna be narrower and narrower as the simulation go, because all the agents are gonna point to that specific point, and we really don't want that. We want to keep like the formation a bit a bit spread out, so that we don't have intersections and the simulation looks nice. So I put the follow target here. I'm gonna drag and drop the curve here, and now if I press play, the agents should avoid the meshes and also avoid each other. So that guy over there did both. Actually, let me put a bit more frames. So now what we need to do is we have to start fiddling with all the parameters of all these modules to make the simulation looks good. For these kind of scenarios, I would definitely recommend using a different approach, like using a curve field, or more than one curve field. And there's also an example in the demo folder of Atoms. We're gonna build another example later, so you can see better what I mean. But that's the best way to keep the simulation driven by the artist and not by some module, because by using the module the problem is that you're not really controlling the simulation, and then if you have to edit it in some way, it becomes harder and harder, as opposed as if you have the tools for actually making the simulation art driven. Okay, so now let's go back to the simulation. Let's stop talking and press play. Let's see what's going on here. So it looks okay. That guy is doing a bit of going back and forth, but they are all looking pretty good to me. There are a few things that we might want to consider whenever you are playing with this kind of scenario. So the first one is that the context steering, you need to allow some max turn angle. The default is 4, which is good in this example, but if you have like a more packed area, you need to set this value to a higher value, maybe 8 or 10. You'll see sharper turns, but you know, if you want the agents to avoid each other, that's what you have to do. So 8, actually we could try here just quickly to make the agent group a bit narrower from the beginning, so we might see what I was meaning. So let's see if the agents are actually, they're still looking okay. That guy there got confused for a second, but it looks okay. The fact that we have added like a target curve, it really increases the quality of the simulation by far. If you don't add like a target point in this kind of scenarios, you're gonna see a lot of funky stuff going on. So always try to add like some target points for your agents. One thing that also might help the simulation when you play with this stuff is enable the use param. With this value, basically you're saying to the agents, get a point on the curve at the beginning of the sim, and always try to follow that point. If you don't have this on, it will always try, the agents will always try to find a new point in on the curve during the sim. So let's see again how it's going on. Also, what this will do, the use param, it will also make sure that the agents will start spreading out once they pass the obstacles here. That's great. One thing, you might have seen some agents here getting a bit confused and going a bit all over the place. What you could do is like we could increase the distance for the mesh avoidances, because here, for instance, here we have 200, and if you have the same distance for the mesh avoidance, the same distance as the agent avoidance, then you might end up having like you know, this kind of fighting between the agent avoidance and the mesh avoidance still. So with 400, we're making sure that the agents have plenty of times for avoiding the meshes and still having time for avoiding the agents. So let's see. I might be wrong, but you know, like you can still play with these parameters as you go and see what creates the best result for you. Yeah, there was like an agent over here that was still intersecting with the mesh. You might not be able to find you know, like a perfect simulation, but you know, like you can help it as much as you could. So here, let's just increase the max turn angle by a few degrees, so maybe that agent will have enough you know, like it will be able to turn enough quickly enough so that they won't intersect. It's just that the problem is that it's also playing with the mesh avoidance here, so that's what's happening there. Okay, so yeah, I think this is it for this example, and we can have a look at the curve field now. Okay, so now let's have a look at how we can actually make a mesh and agent avoidance like very artistic. So we're gonna do everything manually, and we're not gonna use mesh avoidance or agent avoidance or context steering at all. So as you see here, it's the same scene as before. What I've done, just I've created some curves. So these two on the outer side, and then these ones, so 2 per obstacle. What we can do is we can go on the agent group, we can add a curve field. So the first one is gonna drive the agents, so you can drag and drop the curves here with the middle mouse button. So the first one is using the outer curves, like this one. So the agents are just gonna follow this direction, okay? So this is the initial layout that we had before. You can even change it if you want. The agents now are, of course, intersecting the meshes because they don't have any, you know, we're not telling them to to steer away from them yet. So to do that, we're gonna add a new curve field. We're gonna expand this at the curve 4 and 5, which are these two. Here we can say the max turn angle should be higher than the max turn angle of the first curve field module, which is 5. This is because we need, again, these two are gonna basically override the value of each other, so the result of each other. So this one is gonna override whatever this curve field is doing. If we say 5 for the max turn angle on this curve field, it means that basically we're overwriting exactly, in some cases, the result. We could be overwriting exactly the result of this other curve field here. So what we want to do is we want to set a higher value so we are able to turn away from this obstacle here. And then we want also to provide a max distance. Say I want to activate this curve field only when we're closer than 300 units to these curves. Also provide some fall off, maybe drop off like 50. And this should already work, so we should see the agents avoiding the curves. Also make sure here that the curves, the initial points, they are kind of matching here, because otherwise you could see agents like, for instance, that guy. Yeah, exactly. We want to fix that. I think, yeah, that's it. So let's say control vertex. If the agents actually come perpendicular to that point, then it's gonna have an hard time trying to steer away. So let's see if this fixes it. Yeah, this is better. So we saw some agents are actually still going through the mesh, and this is because just the curve is not perfect. So we could get this point and do this, and this should actually fix it. Could fix it actually. Let's see if we get a better result. You see the agents here, at least they're not going through. On this side I saw already a guy that went through, but anyway, that's the same thing. You just need to change the curve, and we can do the same for these other two obstacles. So we can add two more curve fields, and we could actually we could do this. Look, so the first one we can say so it was 2, 3, 4, 5, then 6, 7, just to make sure that I did 4, 5, yeah, 6, 7. Then we could copy modules and paste modules, but here we should use we should use this curve and this curve. Again, here we want to set the same values that we did for the curve field 1. So this should be max turn angle 10, and then we say 350, if I remember correctly. Yeah, so 10, 350. We press play. This should already take care of most of the, well, like the mesh avoidance at least. And that's it. Yeah, so the mesh avoidance is done, kind of also the agent avoidance. We see there are some agents here, so the question is how we can fix it from here. So you have two options. If you want really to keep the agent there, which actually I should have selected it properly. Sorry, replay. Sorry about that. So let's see which one. There. For instance, this guy over here. We can select with the agent layout tool that guy, not just this guy. Okay. So we could move it on the right just a little bit, like so. So now press play. you have to do this layout, and then you have to replay, of course, because this is a simulation. So we play from the first to the last frame. So it's a bit better. You see, they're not intersecting anymore as before. The other solution is, let's see if there's another guy that is intersecting. Actually, you know what? Like, let's use that one still. So, because it's still selected, so we have it there. Let's just go here in the attribute editor. Whenever you move an agent like that, that creates an offset module if you're using any layout that is not a points layout. So I'm gonna remove it, this one for now. The agent is back now to its initial location. The other thing that you can do is you can, with the agent layout tool activated, so we have still activated the agent layout tool. You can go in here, select, and then delete selected agents. So this is gone now. And it's pretty much like what we did before with the cache reader using the agent deleter, but in this way it's safer because as we're not using an agent avoidance or a mesh avoidance, an agent avoidance, that basically doesn't affect the result of the simulation. We're just filtering out an agent that was just intersecting. So this is an approach that won't change the result of the simulation. We'll just remove that agent if you can't just take that and move it to another location and make the simulation look good. You can of course use the same approach for agents that are intersecting the meshes if you are not able to both have like a good mesh avoidance and agent avoidance by just drawing these curves in your scene. And this is all for this video. Thanks for watching.